Hi, welcome to Mrs. Park's Geometry class. This is Chapter 2, Section 2, Part 2. Alright, so today I'm going to learn a little bit about truth tables. So a convenient method to organize the truth values of a statement is to use a truth table. So these are what truth tables look like. Truth tables can be used to determine truth values of negations and compound statements. Okay, so if you have a statement P and it's true, so when you negate the P, it's not P, so not true would be false. Other way around, if you have false and it's not false, then it would be true. Okay, that was the simple part. And now when we go on to conjunction, alright, so if it's true and you have another statement Q that's true, remember that symbol there means and, kind of looks like a capital A, kind of, sort of. So this means P and Q. So true and true makes it true. Okay. So when you have a true statement for P and Q is false, then you have a true and false, which will make it false. So true and false make it false. If one of them are false, then it's false. Okay. So you have a false and a true statement. If one of them are false, it's going to be false. If you have they're both false and false, false and false will make it false. Okay, good. Disjunction. Okay, so this is where you have the or. Remember, it kind of looks like an R, or. Oops. So if you have like an or statement, it looks like an or. Okay, so that means or. So you have a true and a true. So true or true, it's going to be true. True or false. So if we have all or as a compound, then it can be true or false. So you can choose and it says true. So in this situation, true or false, it can be true. So if you have one of them as true, it's going to be true. Okay? That's why you have all these truth values here. False or false, it's going to be false. Because you have two options, only one option, false or false. So it's false. Okay. To construct truth value tables, to construct a truth table for not P and or Q, not P or Q. Okay. So here is what you're trying to make. You have a P and a Q and a not P. So you have a true, true, not P. So whatever is here, whatever it's in the first column, you're going to do the opposite for the not P column. Okay. So here's true, true, false, 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 true, true. Okay, because this is just not P. Whatever it is, what P is, it's not. So if it's true, it's false. True, false, false, true, false, true. Okay. So first thing they did was make columns with headings that include each original statement, any negation of these statements, and a compound statement itself. So you have P, Q, not P, because you're going to use a not P or Q, because that's what we're looking for. We're constructing a truth table for this part. Okay. List the possible combinations of truth values. So when you list them, you're going to do all the possibilities. So true, true, false, false, true, false, true, false. And then you will find out what the or will be. So you have a true or false. It's going to be true. False, false is false. False, true is true. False, truth is true. So use the truth values of P to determine the truth values of its negation. So we did that. Anything what P is, not P is the opposite. So when you're combining these with the or, okay, anytime it has a truth in it, it can be true when it has an or button, or symbol. When anything is false, false, it's going to be false. Okay, that might sound really complicated, but it might be easier if we do a little bit more practice in class. Alright, so here's your turn, and I'm going to help you out a little here. So you're going to do a truth table for not P and not Q. So you need a P, you need a Q. You need a not P, and you need a not Q. And then you need another set column for not P and not Q. Okay. 1, 2, 3, 4. Let me get a little bit longer. Ooh, that got real ugly, huh? All right. And you're gonna have 4 columns. Sections. 1, 2, 3, and 4. Hopefully yours will look a lot cleaner than this one. All right. So we're gonna start with true, true, false, false. Okay. Same thing for true, 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 false, false, true, false, false. So I'm going to think of all the combinations that we can make up. Now, not P means the opposite of here. It's the opposite of P. So that was true, so this is false. That was true, false, false is true, false is true. Okay. So not Q means everything that's here but opposite. So false, true, false, true. Okay. Now we're going to combine those. Let's use pink. Combine these statements with an and. Remember that looks like an A, so it's an and. Okay. So not false and not false. Whoops. Whoops. Okay. So not P and not Q. So false and false makes it false. False and true makes it false. Truth and false makes it false. Truth and truth make it true. So there we have it. We just did it all together. So you're welcome. But when we do this as practice, I do expect you to make this chart on your own. Okay. All right, Venn diagrams. Conjunctions can be illustrated with Venn diagrams. Consider conjunction given at the beginning of the lesson. So P and Q, a rectangle is a quadrilateral and a rectangle is a convex. So when you have and, it's going to have a middle part where it's together, it's combined as an and. The Venn diagram shows the rectangle R is located in the intersection of the set of quadrilaterals and the set of convex polygons. In other words, rectangles must be in the set containing quadrilaterals and in the set of convex polygons. So here you have P and you have Q, and the R part here is where it's combined with an and. Okay. A conjunction, a disjunction can be illustrated with a Venn diagram. Consider the following statements. Here we go. Following statement. P, a figure is a quadrilateral. Okay. P, everything is quadrilateral. Q, statement, a figure is a convex. Okay. P or Q, a figure is a quadrilateral or convex. Okay. So here you have what's combined. So P and Q. Okay, it's combined one. Okay, it has to be together. The or part can be all of this, because if you anywhere in this Venn diagram inside this area, it's going to be an or, P or Q. Just the quadrilateral, it's P and not Q. So this part right here, okay, just this area, okay, this is just the P part that does not include any of the Q. And then the right side, this part right here, it's only the Q part and not P. It has nothing to do with the P part, so it's only the right side right here. Okay, not including the middle part. Okay, and that's what all of this is really saying right here. Alright, so here is a real world example using Venn diagrams. Spanish club meeting. Okay. Scheduling. The Venn diagram shows a number of people who can or cannot attend the May or the June Spanish club meetings. How many people can attend the May or the June meeting? So May or June. So anywhere. So this means the part, the blue, the purple, the red, anywhere in here they can attend. So we're going to just add all these numbers. 5 plus 6 plus 14. 5 plus 6, you got 11. 11 plus 14, you got 25. So 25 people can attend either night. Okay, good. Next one. How many people can attend both the May and June meeting? That means it's the and part. So right here, they can do both. Okay, so that says 6. So 6 people can attend both meetings. C. Describe the meeting that 14 people located in the non-intersection portion of the June region can attend. So tell me in words what this means. That means 14 people can attend only the June meeting, but not the May. So only the June 14 people can attend. Okay. Alright, so here's your turn numbers for A through D. So go ahead and pause the video and go ahead and do A, B, C, and D, looking at this Venn diagram about a prom attendance. And when you're done with this, make sure you put this in your book bag so that you can get credit for your homework. And when you're done, you are done.